In this section, we're going to look at circles as a conic section. The standard form of an equation of a circle is x minus h squared plus y minus k squared equals r squared. And this is very similar to an ellipse. It's got the x minus h, it's got the y minus k, each being squared with a plus between them. And the difference is it's got an r squared over here, which is the radius of the circle. And that is the distance between the center and the edge of the circle. And hk is representing the center. R is representing the radius. Just remember that in the formula that r squared is squared, where when you get the radius you have to square root it to see what the radius is. So look at example number 1 and see if you can pause the video and see if you can write the center and the radius and make a little graph of this circle from those pieces of information. So for the center, you should get 3 and negative 2, because remember the equation already has a minus in it, which means you'll use the opposite of face value of what you're seeing right here. And also another way to look at it is it's x minus h, so this is your h, and then y minus k could be written like this, and this would be your k, because these two pluses are going to, these two minuses are going to go to a plus. Then r squared is 16. Remember, that is not r, that's r squared. So r would have to be the square root of that, which would be 4. So now we have our center, and now we have our radius. Those are the only two pieces of information you need about a circle. So we'll go to the next page and graph it. Again, the center was at 3, negative 2. So we put our center there, and I label it C for center. And then the best way to graph it is to go the radius in, like, I kind of think of counting north, south, east, and west. And so you'll count up 4. You'll count sideways 4. You'll count down 4. And you'll count sideways the other way 4. And then I like to draw it in quarters because I tend to draw a better circle that way if I just draw a quarter at a time. And now you have your circle. As you can imagine, at this level of math, we're not going to keep it that simple. Sometimes our conic sections of any type will be written in what we call general form. And general form is when everything is on the left side of the equation, and then on the right side of the equation we just have it equals 0. And so that is called general form. And a lot of times we're going to have to change from general form over to standard form so that we can be able to see the key points and the key information that we need to be able to graph it. And so you can imagine completing the square would be necessary here, and so we're going to complete the square on this particular one. Another thing I want to point out is that you can look at general form and tell what kind of conic section it is, and the reason we know this one is a circle is because between the x squared and the y squared there's a plus, and the coefficients in front of the x squared and y squared are the same. They're both 1. And they could both be 2's or both be 3's. It doesn't matter. It would still be a circle. But this particular one has the plus and the same coefficients in front of x squared and y squared, so we know this is a circle. If they were lopsided, they still had a plus in between them, but one was like a 2 and the other one was a 3, like 2x squared plus 3y squared. That would then be an ellipse because it's not even all the way around like a circle. It's oblong in one direction or the other. And so the coefficients in front of x squared and y squared would be different if it was an ellipse. So let's look at putting this in the standard form by completing the square. What we want to do is we want to get the x squared and the x term next to one another. So we're just rearranging it a little bit. And then we put plus blank to fill in the spot for completing the square. We kind of leave a spot for that. And then we put plus y squared, and then we get the y term next to it, and add a spot for completing the square. Then, if there is any other number on this side, what you want to do is get it off that side to get it out of the way, and so we will add 8 to both sides, which makes that equal to positive 8 on the other side. Now we're ready to complete the square. And then to remind myself to balance out on the other side of the equation, whatever I write in the blanks, I'm going to write on the other side of the equation as well. I just kind of ran out of room there, but I would normally write it next to the 8. And that way I'll remember to, whatever I fill in the blank on the left side, I'm going to fill in the blank on the right side. So for the first polynomial that I'm trying to complete the square on, I want to always look for the x term or the y term, and that is what I'm going to take half of. So I always take half of the positive 8 in this case, and that gives me 4. And then that number is going to be important for the next step, which is kind of the factored step. And if it's positive 4, you're going to write x plus 4 on the next step. Then, to continue that, we're going to take whatever that number was, and we're going to square it. And that number is important because it's going to be what we need to write in the blank to complete the square, or complete the polynomial so that it's a perfect square polynomial. And the reason this works is because right here we have a trinomial that could be factored into x plus 4 times x plus 4, and therefore we get this x plus 4 squared. But I always just do the shortcut where I put the half number there and the squared number up there. And then when you write the squared number in the blank, you also want to write it in the other blank on the other side of the equation to make sure it's balancing the equation. Then for the second half over here, we have another trinomial if we just look at that half. And we want to take half of, in this case, the negative 10 that's in front of the y. And when you take half of negative 10, you actually get negative 5. By the way, you won't always have even numbers, and so if you have to take half of an odd number, you'll just have a fraction. Like if it was half of 7, you'd have 7 over 2. And that's fine. You just use that number. But this one turns out nice. It turns out to be a negative 5. And that negative is important because when you write it in the factored form, it's y minus 5, because that negative 5 will come into play when you write it in there. And then once we square it, we have negative 5 squared. It will go back to a positive 25 in this case, and so you're completing the square number will always be positive when you end up writing it in here. And then whatever you write on the left side blank, you have to also write that in the right side blank. And so we're almost there. We just need to add up these numbers. And so if you add up 8, 16, and 25, that's what will go on the other side of the equal sign. So that will be 49. And then we'll have a plus in between here, which is just coming down from the previous step. And you can see that we have our equation of the circle in standard form. And as you have seen on the previous slides, the standard form is important because then we can just pull off the center. We can look right at it and see the center. It is the HK, and remember you use the opposite signs of what you see there. And then you have a radius of, this is radius squared, and so radius is 7, which is the square root of that. And you can use these two pieces of information to graph or do whatever you need to do. So getting it in a standard form is important, and you'll have to know how to complete the square to be able to do that.